Hello, my name is Narathip Ratanavipanon. I'm a senior computer science engineering at University of Michigan. In summer 2012, I worked for a short program. My research was about unsupervised feature learning and deep learning with Dr. Ufldl.
So this project heavily involves with both computer vision and machine learning. We also have two goals in this project. The first one is to detect the location of cars in any given image frame, and the second one is to tell if there's any car in any given image by using 2D image and 3D point cloud information. Basically, we can split this project into two important parts: detection and classification. For detection phase, we use filters to sweep through the entire image to find the location of cars if there are any, and the right images are the car filters that we use in our detection. Here's the result from the detector. As we can see, it can detect most of the cars in each frame. However, there are still a lot of false bounding boxes, such as the one on the sky on the left image, and a lot of big bounding boxes on the right image. So we need to find a way to remove these for detection, and a classification is obviously an answer. Before we move on to the classification pipeline, I would like to introduce the point cloud. The point cloud is a set of points in 3D space, which in the real world are normally generated from a 3D scanner. Here's the visualization of a car's point clouds with three different point of views. The left one is the side view, and the middle one is the top view, and the right one is also the side view. The point cloud is important to the classifier because point clouds contain a lot of information that 2D image doesn't have, such as an angle of a car, a depth of a car. In classification, it feeds an image and point clouds that corresponding to that image into a classification engine, and finally the output will tell if it's a car or not. The classification engine consists of three important parts, which are feature extraction, unsupervised feature learning, and classification algorithms. Also, I include the name of all algorithms that we used inside the green box. Now, one interesting question is, how do we combine the detector and the classifier? One simple solution is to feed the whole image to the detector. Then it will try to detect the car in that frame and output the location of the candidates. But we know for sure that out of those candidates, some of them are false detection. So we send these candidates to the classifier in order to remove the false detection. And if everything works perfectly, only true detection will remain after the classifier. This is one example result from the detector and the classifier. The left image is the output from the detector, and the right image is from using the classification after detection. As we can see, the classifier can remove three false detections on the right image, whereas the true detections still remain. Here is also another good example how the classifier removes the false detections, as the left image is an output from the detector and the right image is from the classifier and the detector. So that's it for my presentation. I would like to thank Dr. Lee for this wonderful opportunity, as well as Shu and Charlie for helping me out with this project. Also, thanks for listening. Bye bye.